Imagine taking your very first breath in a world that has no hospitals, no medicine, no warm nursery waiting for you. The air is colder than your body is ready for. Every sound is unfamiliar. Every sensation is overwhelming. You cannot lift your own head. You cannot crawl toward safety. You cannot even shiver properly to keep yourself warm. Somewhere beyond the circle of your family's camp, predators roam the landscape, always searching for an easy meal. And to them, a newborn human is exactly that. By almost every measure, you shouldn't survive. A newborn giraffe is standing within an hour. A foal quickly learns to run beside its mother. Even chimpanzee infants, our closest living relatives, cling tightly to their mothers almost as soon as they're born. Human babies, on the other hand, can do almost nothing. They rely on someone else for every heartbeat of their existence, every meal, every movement, every moment of warmth. Strip away that care for only a short time, and survival becomes impossible. Yet here you are. Your existence means that this seemingly impossible challenge was solved again and again, generation after generation, stretching back roughly 300,000 years. Every parent, every grandparent, every ancestor in your family tree succeeded where countless others did not. If just one infant in that unbroken chain had failed to survive, your story would have ended long before it ever began. That makes this more than an interesting question about prehistory. It's one of the most personal questions we can ask about ourselves. How did ancient humans keep something so astonishingly fragile alive in one of the most dangerous environments our species has ever faced? The answer isn't hidden inside a forgotten survival manual or a single revolutionary invention. Instead, it lies in a collection of behaviors so effective that they reshaped the course of human evolution itself. In many ways, these behaviors became our species' greatest adaptation, not sharper teeth, stronger muscles, or faster legs, but an extraordinary capacity to care for one another. Before we can understand how our ancestors protected their children, though, we need to answer a different question. Why are human babies so helpless in the first place? Because that vulnerability wasn't an accident of evolution. It was the price our species paid for becoming the most intelligent animal the world has ever known. That price came in the form of an extraordinary evolutionary trade-off. Your brain is astonishingly powerful, capable of language, abstract thought, imagination, and technology. But long before it allowed humans to paint cave walls, cross oceans, or build civilizations, it created a serious evolutionary problem. Quite simply, our heads became too big. Evolution rarely produces perfect solutions. Instead, it settles for compromises that work well enough to keep a species alive. In our case, two major changes happened at the same time. Early humans evolved larger and larger brains because greater intelligence offered enormous advantages. Individuals who could communicate more effectively, solve problems, cooperate, and adapt to changing environments were more likely to survive and raise children of their own. Over hundreds of thousands of years, natural selection steadily rewarded bigger brains. At the very same time, another change was taking place. Our ancestors had committed fully to walking upright. Bipedalism transformed the human body, freeing our hands to carry food, make tools, and eventually care for infants. But standing and walking efficiently required a narrower, more stable pelvis than the one our ape ancestors possessed. Those two evolutionary successes collided in one unavoidable place: childbirth. A baby's head had to pass through a birth canal that could not simply keep expanding without making upright walking far less efficient. For generations, scientists referred to this conflict as the obstetric dilemma, and although researchers continue to debate exactly how much each factor contributed, the central idea remains remarkably important. Human evolution found itself balancing two competing demands. We needed large brains, but mothers also needed to survive childbirth. The solution wasn't to make babies smaller forever. It was to change when they were born. Compared with almost every other primate, humans enter the world at an unusually early stage of development. Scientists call this secondary altriciality, a technical phrase that simply means human babies are born before much of their development is complete. Think of it as shifting part of pregnancy outside the womb. At birth, a human brain is only about a quarter of its adult size. A chimpanzee's brain is nearly twice as developed relative to adulthood. That difference may not sound dramatic at first, but it completely changes the first years of life. While many mammals spend their earliest weeks learning to walk or forage, human infants spend those same months building billions of neural connections that will eventually support language, memory, creativity, and reasoning. In other words, the incredible brain that defines our species isn't finished when we're born, it's still under construction. That unfinished development comes with enormous risks. A newborn cannot gather food. It cannot escape danger. It cannot regulate its body temperature effectively. Even something as simple as rolling over is months away. Survival depends entirely on someone else responding when the baby cries, carrying it when it cannot move, and protecting it from a world it has no hope of understanding. This vulnerability wasn't a flaw in the human design. It became one of the driving forces behind what made us different from every other human species. Once infants required years of intensive care instead of weeks or months, raising children stopped being a challenge that one individual could solve alone. For our ancestors, intelligence and cooperation became inseparable. The larger our brains grew, the more dependent our children became. And the more dependent our children became, the more essential it was for entire groups, not just parents, to work together. That realization changes the question completely. Ancient humans didn't succeed because they discovered a perfect parenting technique. They succeeded because they transformed childcare from an individual responsibility into a shared survival strategy, laying the foundation for one of the most remarkable social systems ever to evolve. As human children remained dependent for longer and longer, another evolutionary problem emerged. Even the most capable mother could not hunt, gather, defend herself, and provide constant care for an infant every hour of every day without eventually reaching her limits. If raising a child required years of uninterrupted attention, then the survival of that child could no longer rest on one pair of hands. Our ancestors solved this challenge in a way that is remarkably rare among mammals. Instead of making mothers do everything alone, they spread the responsibility across an entire community. Anthropologists call this cooperative breeding, and it may be one of the defining features of what made Homo sapiens so successful. In this system, children were not simply the concern of their parents, they became an investment shared by the group because every healthy child increased the community's future chances of survival. One of the most fascinating pieces of evidence supporting this idea is known as the grandmother hypothesis. At first glance, human menopause seems unusual. In most animals, females continue reproducing until very near the end of their lives. Human women, however, often live for decades after having their last child. Rather than viewing this as an evolutionary mystery, anthropologists such as Kristen Hawkes proposed a different explanation. Older women may have increased the survival of their own genes more effectively by helping raise grandchildren than by continuing to have children themselves. Research from traditional hunter-gatherer societies offers compelling support. Children with actively involved grandmothers are often more likely to survive, receive better nutrition, and reach adulthood. Experience, it turns out, became as valuable as youth. A grandmother who knew where food could still be found during a drought or how to calm a sick infant was passing on knowledge every bit as important as DNA. The circle of caregivers extended well beyond grandparents. Fathers carried infants, protected camps, and shared food. Older brothers and sisters watched younger siblings while adults worked. Aunts, uncles, cousins, and unrelated members of the group all participated in what researchers call alloparenting, care provided by individuals other than the biological parents. Studies of modern hunter-gatherer communities, which offer valuable insights into ancient lifeways, consistently show infants moving through a network of attentive caregivers rather than remaining with one adult throughout the day. Compare that with the family structure many people know today. In much of the industrialized world, childcare often falls primarily on one or two adults, sometimes living hundreds or even thousands of kilometers from relatives. From an evolutionary perspective, that arrangement is surprisingly new. For most of human history, children were never meant to grow up at the center of a single household. They grew up at the center of a community where the strength of the group ensured that no child's future depended on one exhausted caregiver alone. And nowhere was that shared responsibility more visible than in the way infants were cared for each day. If you had watched an ancient human camp at almost any moment of the day, one thing would have stood out immediately. Babies were almost never lying by themselves. They weren't parked in cribs or left in sheltered corners while adults worked. More often than not, they were pressed against someone's chest, wrapped in animal skins or woven slings, moving through the landscape as an extension of another human body. This wasn't simply a convenient way to transport an infant, it was the operating system that human childhood evolved to expect. Constant carrying solved several problems at once. A baby held against a caregiver stayed warm without expending precious energy. It remained protected from predators and environmental hazards while the group searched for food or traveled between camps. Just as importantly, the caregiver could respond immediately to hunger, discomfort, or danger, long before a minor problem became a life-threatening one. Modern neuroscience helps explain why this strategy was so effective. A newborn's nervous system is still under construction. Many of the systems that regulate heart rate, breathing, stress hormones, and even body temperature are immature at birth. Physical contact acts almost like an external support system, helping stabilize functions the infant cannot yet manage independently. Skin-to-skin contact has been shown to lower stress, regulate breathing, and improve temperature control. Benefits so reliable that hospitals around the world now use it routinely for premature babies. Even crying begins to look different through this evolutionary lens. Today, it's often treated as a behavior that needs to be managed or corrected. But for most of human history, crying was an emergency signal. A baby left alone was cold, vulnerable, and potentially attracting predators. The distress wasn't manipulation. It was a survival alarm honed by natural selection. Studies of hunter-gatherer societies show that infants who are carried throughout the day cry substantially less than those who spend long periods separated from caregivers. Their needs are often met before distress escalates because another person is constantly aware of subtle changes in movement, breathing, or expression. Seen this way, physical closeness wasn't an optional parenting style. It was the environment in which the human brain expected to grow. For hundreds of thousands of years, our earliest experiences of the world came through another heartbeat, another voice, and another pair of arms, a pattern that would continue to shape one of the most important relationships in a young child's life: the bond between nourishment, comfort, and human connection. Keeping an infant close solved one challenge, but another remained just as demanding. The human brain grows at an extraordinary pace during the first years of life, consuming far more energy than the brains of other young primates. Feeding that growth required a strategy that was every bit as remarkable as the social system surrounding it. For most of our evolutionary history, breastfeeding continued far longer than many people imagine today. In hunter-gatherer societies, children commonly nursed for 2 to 4 years, sometimes even longer depending on environmental conditions. Far from being unusual, extended breastfeeding was the biological norm. Mother's milk provided not only calories but also antibodies that protected against disease, hormones that helped regulate development, and a reliable source of nutrition during seasons when food was scarce. It also shaped the rhythm of family life in an unexpected way. Frequent nursing naturally suppresses ovulation in many women, delaying the next pregnancy. As a result, children in traditional hunter-gatherer populations are often spaced about 3 to 4 years apart. That interval gave each child time to become stronger and more independent before another infant demanded the same intense level of care, reducing the burden on both mothers and the wider group. Even so, mothers were not always the only source of nourishment. Across many traditional societies, women breastfed children who were not biologically their own, a practice known as wet nursing. If a mother became ill, died, or simply needed help, another lactating woman could keep the infant alive. Beyond its practical value, this created stronger social bonds between families, reinforcing the idea that every child represented a shared investment in the community's future. Eventually, however, milk alone was no longer enough. Without blenders or packaged baby food, caregivers relied on techniques that seem unusual today but were both practical and effective. One of the oldest was pre-mastication, adults chewing food before passing it directly to an infant. While modern hygiene understandably raises concerns about this practice, it also transferred beneficial microbes from caregiver to child. Scientists now recognize that these early microbial communities help train the developing immune system, suggesting that ancient feeding practices may have influenced health in ways our ancestors could never have understood. The foods themselves were remarkably diverse. Bone marrow offered concentrated fat for a rapidly growing brain. Soft fruits, mashed roots, eggs, fish, and finely shredded meat introduced children to the same varied diet eaten by the rest of the group. Archaeological studies of ancient teeth reveal an intriguing pattern. Hunter-gatherer children generally experienced fewer cavities and signs of nutritional deficiency than many children who lived after agriculture became widespread. A menu built from dozens of wild plants and animals often proved healthier than one dominated by cultivated grains, reminding us that the earliest human diet evolved to nourish not only growing bodies, but also the remarkably expensive brains that made our species unique. Yet even the healthiest diet could not shield children from every danger of prehistoric life. No matter how carefully ancient humans raised their children, they faced an enemy they could rarely see and never fully understand. Infection, injury, parasites, harsh winters, and periods of famine claimed countless young lives. By modern standards, infant mortality was devastatingly high. In many prehistoric communities, perhaps a third or even half of all children never reached their fifth birthday. That reality wasn't the result of neglect. It reflected a world without antibiotics, vaccines, clean water systems, or any knowledge of bacteria and viruses. Yet, our ancestors were far from helpless. Over thousands of generations, they accumulated practical knowledge through observation, experience, and trial and error. Certain plants were repeatedly chosen because they eased pain, reduced fever, or helped wounds heal. Long before chemistry explained why, people had discovered that willow bark could relieve aches because it contains compounds related to modern aspirin. Honey was valued not simply as a rare source of sweetness, but because it slowed infection when applied to cuts and burns. Garlic, now known to possess antimicrobial properties, found its place in traditional remedies across many cultures. None of these treatments could cure every illness, but together they improved the odds often enough to become enduring traditions. Just as important as these remedies were the rituals surrounding birth and childhood. To modern eyes, protective charms, naming ceremonies, and communal prayers can appear to be little more than superstition. Anthropologists, however, see something deeper. These rituals strengthened social bonds by publicly declaring that a newborn belonged to the entire community. They reminded every member of the group that the child's survival was a shared responsibility, while also providing families with a way to cope when tragedy struck. The archaeological record tells a surprisingly emotional story. Infant burials from prehistoric sites are frequently marked by extraordinary care. Tiny bodies were placed deliberately in graves, sometimes accompanied by beads, tools, flowers, or other grave goods that carried meaning for those left behind. Such discoveries leave little doubt that parents grieved deeply for the children they lost. Love, mourning, and hope did not appear with civilization. They were already woven into human life tens of thousands of years earlier. Even in a world where death was common, ancient humans refused to accept it passively. They observed, remembered, and shared what seemed to work, passing hard-earned knowledge from one generation to the next. Medicine was still primitive, but the instinct to protect children through both practical care and collective compassion had already become one of humanity's most enduring strengths. By now, a pattern has emerged. Ancient humans did not overcome the vulnerability of childhood through a single breakthrough. They built an entire social system around it. For hundreds of thousands of years, children were raised within a dense network of parents, grandparents, siblings, relatives, and trusted companions, each contributing in ways both large and small. That environment wasn't a luxury. It was the setting in which the human mind and body evolved. Over the past 2 centuries, however, that landscape has changed dramatically. Industrialization drew families into cities, work moved away from the home, and extended families became increasingly scattered. In many parts of the world, raising a child shifted from being a shared responsibility to one carried primarily by 1 or 2 adults. Parents today often find themselves navigating the demands of infancy with far less day-to-day support than their ancestors could have imagined. Modern research suggests that this isolation comes with real consequences. Rates of parental burnout, postpartum depression, and chronic stress are particularly high in societies where caregivers lack strong social support. The problem isn't that today's parents are less capable. It's that many are attempting a task our species evolved to accomplish collectively. That doesn't mean the ancient world offers a blueprint we should simply recreate. Modern medicine has transformed childhood in ways our ancestors could never have dreamed possible. Vaccinations, antibiotics, clean drinking water, neonatal intensive care, and improved nutrition have reduced child mortality to levels unprecedented in human history. Millions of children are alive today because of these advances, and no evolutionary tradition can replace them. What ancient societies still offer, however, is a reminder that biology has not changed as quickly as culture. Many practices that once emerged through necessity, responsive caregiving, prolonged physical contact, breastfeeding when possible, and strong community support, continue to receive support from modern developmental psychology and neuroscience. The greatest lesson from our ancestors is not that they had better medicine, it's that they understood, through experience alone, that raising a child was never meant to be a solitary endeavor. Think back to where we began. A newborn enters the world unable to walk, unable to feed itself, unable even to survive a single day without someone else's protection. By every conventional measure, it seems like an impossible way for a species to succeed. Yet, that extraordinary vulnerability became one of humanity's greatest strengths. Instead of evolving sharper claws or thicker hides, our ancestors evolved something far more powerful. They learned to cooperate. Every generation passed down not only genes, but knowledge, experience, and compassion. A child's survival depended on mothers, fathers, grandparents, siblings, and countless other hands working together. In protecting their youngest members, ancient humans were also protecting their future. That legacy is still written into us today. The comfort a baby finds in a familiar heartbeat, the instinct to respond to a child's cry, the deep satisfaction of caring for another person. These are not modern inventions. They are echoes of a survival strategy that carried our species through hundreds of thousands of years of uncertainty. Our technology has transformed the world beyond anything our ancestors could have imagined. But the biology that shaped us has changed very little. The story of how ancient humans kept children alive is, in the end, the story of how humanity survived at all. Not because we were the fastest, the strongest, or even the smartest animals on Earth, but because we discovered that our greatest advantage was each other. Intelligence helped us understand the world, but compassion allowed us to endure it. And perhaps the most important adaptation our species ever evolved was never the size of our brains. It was our extraordinary ability to care for one another,